In this video, I'm going to show you how I made my Tetris game in Raylib. Now firstly, I'm a beginner in C++. The whole reason why I made this game is to learn how to make games using C++ and to better learn how a game engine works. So if you see some mistakes in my code, well now you know why. Also, I made this game using Javadoc09's Tetris tutorial. So there is a lot of similarity in code, except for a few additions I have made. So I'm not going to explain each and every single thing I have done in here to keep this video short and simple. I highly recommend you to watch this video if you want to know more. But I'm going to do a quick overview of what I have done in here and some changes I made to make this work in Raylib. And the source code for this game is available in my Patreon. So if you like what I do, you can support me over there and I would really appreciate it. So I'm going to first quickly explain how this code over here works before explaining what this one does, and you will know why in a minute. So in this code, we are storing the character 9 that will act as the boundary of our playfield. And the playfield is the area where we can move our tetromino pieces, and then the character 0 will be the empty space in our playfield. And both of those are stored in this character array called C field. So if I were to run the game, you can actually see it. So over here, you can see the hash symbol over here, and this acts as a boundary for our playfield, where our tetromino blocks, which are these ones that we can actually control, cannot move beyond these two boundaries over here. And I will explain how this character 9 became this hash symbol later on. And in the code above, we are storing a bunch of white space characters in another character array called screen. And later on, all the characters stored in our C field array will get stored in our screen array instead. And the reason we are doing it this way is because I want to handle the rendering of the tetromino block that we are controlling separately from the blocks present in our playfield. So whenever we score a line, we can easily delete them off and move the rest of the blocks above downwards, just like how it works in almost every Tetris game. You will get a better idea of how we do this later on. So I'm going to scroll down over here onto our code for creating the tetromino blocks over here. So the dots in each of these string array elements represents empty space, and the X represents the position of the actual block. So we only use the X in here for detecting any collisions and for rendering our blocks. So scrolling down further, you can see we have declared and initialized all these variables over here, and we will use all these variables later on in our actual game loop. You can see the template code over here for creating our game window in Raylib. And then you can see this for loop over here. This for loop is used to randomly choose any 3 tetromino pieces at the start of the game. So the first piece chosen will be the piece that we will be controlling at the start of the game, and the other 2 pieces chosen that will be stored in this array, the NP selector over here, and this will be displayed at the upcoming pieces area. And if I were to run the game, you can actually see this. This is the upcoming pieces area over here, and you can see the 2 pieces that are going to spawn next. And just below it, you can see the code for using a different font in Raylib, and I'm using this font to make our game over text look a bit nicer. And after that, you can see the while loop over here, which is the main loop in our game. So everything in this loop will execute 25 times per second, and that's controlled by this function over here, which is also a function from Raylib. So you can kind of change the frame rate by changing the number over here. And inside this while loop, we are constantly checking whether the boolean variable bGameOver is true or not. And if it's true, it's only going to render the game over text and the score onto our screen, as we saw before. And now, inside our actual game loop, it's actually divided into a couple of sections over here, such as the game tick, the game logic, the display, and so on. And the first section that we're going to look at is the game tick. So this block of code over here is basically used by other parts of our code to time their functions properly, and we will come back to this later on. The second section of our code is the game logic, and this is split into a bunch of other subsections over here, So the first thing we do is check for the player input over here, and if there is a valid input, we then check if there is anything stopping us from moving into the direction we want to move. And we check for that using this function called doesPieceFit, which is our function for collision detection in this game. So if both of these are true, then we get to move our piece in that direction. After that, we have the code that deals with moving our current piece down the playfield every second. So this entire if code block over here will only execute once every second, and the timing for that is controlled by this bit of code over here in our game tick. So over here you can again see our piece is getting forcefully pushed downwards the playfield without me even pressing the keyboard every 1 second. And if our current piece can't be moved down because there is something blocking its way, then we will first convert our current piece at its current location as part of the playfield. The playfield and the piece we control are drawn separately, and we won't be able to control that piece anymore since it's now part of the playfield instead. So after that, we check if there's any lines in our playfield. And again, lines basically mean that there's a complete row of tetromino pieces in our playfield. So we check the entire playfield, there's any line in them. And if there is any line, which is determined by this variable over here, then we will set the entire row of that tetromino blocks into this symbol over here. So we basically store all of that into our variable called vlines over here, which we actually use to kind of delay deleting our row of tetromino blocks. And this variable is used in another part of our code over here, and we will execute this block of code after a delay of about 1 second, which is controlled by this block of code over here. So when both of these conditions are true, then we will delete the lines and move all the blocks above down the playfield to fill up this space. This is done to give a more visual feedback to the player for getting a completed row. And that's what happens when you create a line. There was a delay of about 1 second before the pieces got removed, and the rest of the pieces above it got pushed downwards. So back over here, we have the code for calculating the score, then we have the code for picking a new piece and updating our upcoming pieces and positioning our new piece at the top of the playfield. Then we are increasing the difficulty of our game by reducing the time between each tick and thereby making our blocks move down the playfield faster for every 50 pieces we spawn. And if the piece does not fit straight away, then it's game over. After this, we have the display section of our code, and in here we have the code for storing all the elements in the playfield into the screen. So you can see in this line, I am converting the numbers that were stored as characters inside this array into an integer by subtracting the character 0 from it. You can see I have made comments about it. So if I were to scroll above, you can see we were storing the numbers as characters instead of integers over here. And over here, whenever I was storing int values into our character array, I was adding the character 1 into it as well. And I'm doing it this way because a character takes up only 1 byte in memory, unlike an integer that takes up 4 bytes of memory. So for an array containing lots of integer numbers, you would have to manually deal with memory. So it's easier to use the character array instead. And I'm strictly using numbers to store all this because I wanted this line of code over here to work properly. So each time this loop executes, we store our new integer value into this variable called index. This variable is part of this bit of code over here. So if we have any number from 0 to 9 in our index, we will use a corresponding character over here. So if we have 0 in our index, then we will store a white space character or an empty character into our screen array over here. Similarly, if we have the number 9 as our index, then we will use the hash symbol. And this equal symbol will be used if our index is actually 8. And the rest of the characters from A to G each represents a tetromino block, which is based on the index of the tetromino string array. So if I were to give a different symbol over here, for example, this symbol over here instead, you can see our game now looks a bit different. And after that, we have the code for storing the current location of our tetromino blocks or current piece into our screen array. So we can render that out. And after that, we enter the draw section of our code over here, where we actually render out all the characters stored in our screen array. So at the start over here, we have some functions that are necessary for getting Raylib to render all the things properly. So everything we are going to render in our game window or screen needs to be within the begin drawing function and the end drawing function over here. And then within these two functions, we are checking if the boolean game over variable over here is true or false. So if this variable is true, that means our game is over. It's going to render out this section of code over here. And if it's not, if our game is still not over, then we are going to first render a bunch of rectangles which are there just to make our game look a bit nice. And then we will render out all the elements stored in our screen array over here to our actual game window. And we are doing that by using this character variable called temp to convert each character that is stored in our screen into a string. And we are doing that by adding this null terminator at the end of each character over here, which means our strings only have one character in it. And the reason why we are doing this is because our draw text function over here only accepts strings. So I have to convert each character into a string to render them out. And inside the draw text function, I'm using this int variable called n cell size over here, which is there to basically make sure our characters are rendered out at a certain distance from each other. And we have a function over here called select color. And this function is used to give a specific color based on which kind of character is stored in our screen. So if I were to run the game again, you can see the borders of our playfield are blue in color, and each of our tetromino pieces have its own unique color, and the color is determined by the type of character that is stored in our screen array. So if I were to open up this function over here, you can see we're using a switch over here to check which kind of character is stored in our screen and assign a color to it. And by doing it this way, we can make our game look a bit more nicer while also being able to avoid adding any more unnecessary code in our game. After that, we have the code for drawing out our upcoming pieces. So we are drawing out the first upcoming piece and the second upcoming piece using the same method as we saw before over here. And then we have this code over here, which is going to display our current score in our game. So yeah, I guess that's about it for this video. Thanks a lot for watching and see you later. Bye.